towards full control. Understanding man-made weather. Wayner Banham writes, by providing almost total control of the atmospheric variables of temperature, humidity, and purity, it has demolished almost all the environmental constraints on design that have survived the other great breakthrough, electric lighting. In order to understand why we use air conditioning, it is important to first consider how the air conditioner works. Air conditioners run on a cycle. They rely on a number of components to maintain this cycle. These components include a fan, a condenser, an expansion valve, a blower, an evaporator, a compressor, and a second expansion valve. This series of components brings us one step closer towards a well-tempered environment. The lifeblood of the air conditioner is the refrigerant. The fan serves to pull hot air from the condenser outside. The condenser, or heat exchanger, is the coil system that deals with the hot refrigerant. The first expansion valve restricts refrigerant flow. By reducing the pressure of the refrigerant, the temperature changes from hot to cold. This part of the system is high pressure to low pressure. The evaporator is the coil system that deals with the cold refrigerant. The blower pulls room temperature air over the cold coil. This cold air is then sent back to the room. During this process, the refrigerant turns from a liquid to a vapor. The compressor, in conjunction with the second expansion valve, work to raise the pressure of the refrigerant from low to high. As the high pressure refrigerant cycles back to the condenser, the refrigerant becomes a liquid, as it was at the beginning of the cycle. While the mechanics are complex, the machine is extremely easy to use. It is for this reason that air conditioning begins to play into architecture. Banham writes, for anyone who is prepared to foot the consequent bill for power consumed, it is now possible to live in almost any type or form of house one likes to name in any region of the world that takes the fancy.